Hello, my friends. My name's Nico Harkenrider, and if you don't know me, I was here last year on the school. I was on the Science Olympiad team, and I did a robot tour. So today I'm going to explain some mistakes that I did and how you could be better than I did, and hopefully bring home some more medals too. I'd like to see that. So my biggest mistake was custom number one. It was custom designing robots. Now, I say biggest mistake in terms of if you're trying to win, don't, for your first robot, custom design it. You want to figure out first how this electrical stuff works and how components go together, mesh together, fit together, and what things you need to improve. You want to learn by yourself. Now, in terms of learning overall for your future, yeah, I loved custom designing and I learned a lot from going through my 3 attempts of robot creation. But custom designing was definitely one of my biggest falls. Number two, on top of custom designing, this was actually the main contributor to why I consider this a mistake. It is that I started too late. So let's go over here to V1 real quick. This is V1. This is my first robot. It has two really good stepper motors, and just a switch. So you can code it and then it will move super accurately, but super slowly. And I wanted this robot to do more, but I couldn't get it to do more. And the reason why is because I started 1 week before our first competition. And the only reason I was able to do that, I do not recommend starting this late, guys. Do not start that late. Because the only reason why I did decent, and I did pretty good, but the only reason I did that good was because I had a 3D printer and I was able to custom design different modules to get everything to hook together properly. Like these wheels and these housings, they don't come with the motors. The housings, you have to make that on your own and figure out a way to mount it, which is also why custom designing, there's a weak spot to it. Let's get version 3 of my robot over here. Let's go over here. All this stuff, you see my Hall effect sensor and my wheel and my motor housing and also this block, all of this stuff, I had to go in a different program and design on my own. It did not come with the parts that I'm buying, and it doesn't come. You just get the components. So if you're really, I don't know a better word, but then stubborn and custom design your own robot, just keep that in mind that you should have a 3D printer. And guys, if you're looking for a 3D printer for any of your projects, go to Mr. Collins' room. He has a very nice Carbon X1, and I've printed a bunch of stuff on it before, and I love it. It's very easy to use. Just download the Bamboo Slicer, blah, 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 blah. And I also bought another roll of filament for you guys. So enjoy that to your will. Then my third mistake. Let's erase this. My third mistake was expecting too much, guys. Expecting too much. I had this big idea, I'm gonna use these ultrasound sensors to scan where my robot is, and my robot will create a map, virtually create a map in its own program to figure out exactly where it is on the field, and I'll have calibration markers. Okay, well, for your first year, you're probably not gonna get that much, working, because this is your first year and you don't know what you're doing. If you're like me, I joined Robot Tour. I had no idea what these electronics do and no idea how to program in this language. My mother tongue is Python, and this is in a version of C++, Arduino, what it runs off of. So these are my mistakes, right? And these are in general my big mistakes. But I'll show you guys some things to save you some time too. This stuff you'll just have to learn on your own. But these things you can avoid. Number 1, do not use stepper motors. Stepper motors are great, actually, for your first robot. If you're planning on being like me and being a little stubborn and deciding to make it custom everything yourself, stepper motors are great because they're accurate, but they are slow. I was actually talking to the guy last year that designed this game, and he's like, I actually made the maximum amount of batteries, 6, only because stepper motors get really good and really efficient at 8 batteries. So this game is intentionally designed to go against using stepper motors. We're going to try to go or excuse me, not we, but you guys should go down the path of using DC motors plus an encoder. You could use rotary encoders, you could use optical encoders, but that is your kind of like your bread and butter right there. You know, you're gonna want to use those two for your wheels. Like, there is no doubt about it. Because if you don't know what an encoder is, I'll explain it real quick. An encoder basically, simply, if you have a motor, right, and you have an axle on your motor, and this axle does turn, but how many rotations does this do? I don't know. That is why you have an encoder, which is on something that you'd buy from Amazon. It could be just stuck at the end of this, and this would count how many rotations this axle did, and it'll tell you, and you could use that information to figure out how far you went, because you know the radius of your wheel, and you know how many rotations you went. Boom, easy math. You got how many times you trailed along the path, right? Pretty easy stuff. But that's your encoder right there. And DC motors plus encoder, you always want to do that. Stepper motors, not so great, not so good. Your next thing that you don't want to do is use custom components. And now this is very easily avoidable if you just, I don't know where they got the, what's it called? The kit bots, that's what they're called. But I recommend starting with a kit bot actually, because I think you might be able to cobble something better and understand, okay, what do I need for next time to make this powerful, more stronger, right? My problem that I ran into is that I'm not a designer. I am, I don't have the time. We're in the IA. There's not enough time in a week, time in a day to commit sufficient amount of energy to making your own custom modules, right? With the 3D printer and stuff. That's why I say you buy a kit bot. That's another thing. Let's avoid from these general mistakes real quick. Let's go away from these. And let's talk about your wheels, right? It's like, okay, your wheels. Why is that important? Well, if you already know, Robot Tour is a game where you have this grid, right? And your robot goes to a certain location and you have to avoid certain obstacles along the way. You have to navigate and find the path. But you cannot navigate properly if your wheels suck. What do I mean by this? Your wheels should not be, weird looking. You can't track rotations off of that. The only reason the encoder works is because it's assuming it's perfect circle, and that is not a perfect circle. Make your wheels good, like that. Number 2, make your wheels, grippy. I'm getting the hiccups here. Make your wheels grippy, right? Let's go look at V1 real quick. V1 has silicone glue. I don't know. Maybe the camera could focus. Okay. So V1 has glue over here, silicone glue, so that it doesn't slip. And that's why this robot was so accurate, along with the stepper motors and the silicone glue. It was super accurate, and I actually ended up winning 4th place in one competition and 6th place in another, because V1 was super good at tracking. And if you guys are satisfied with stepper motors and going that route, that's perfectly fine. There's a bunch of cheap stepper motors that take like little batteries. Like this guy only had 4 batteries to run a robot that could win 4th place. Like, you don't have to use all 6 batteries, folks. Okay. What's another thing? Okay. So, when designing, let's get this over here. Boom, boom. We got, you want to have a breadboard. I'm telling you right now, you want this thing. This is called a breadboard. And basically, let's bring this up to the camera. Right there. So, we got positive and negative on this side, right? And what this is really, it's kind of complicated looking. It is not. You have all these holes, and each hole in a row. So, like over here, it says the number, where's it at? Over here, it says the number 3, right? There's numbers going around here. And everything in this row, that means it's connected. So all I have to do is take one of these guys. These guys are called breadboard wires. You could just buy them off of Amazon. I take a strip of this, right? Boom, I have a strip. Now we just go over here, connect it. And now if I have a battery, I could connect that wire over in the same row, and I could connect this to my component. So what this means is that I could easily make stuff happen, modulate stuff. I don't need like a proper setup. I could just go, okay, I don't need a solder, so I just plug it into here, boom, boom, test things out, get your life going. Come on. Use breadboards, folks. Breadboards are good, they're cheap, stuff like that. Let's talk about sensors for a tiny bit too. I know this video is getting kind of long, but you trust me guys, it is worth your time. Sensors, you have your ultrasonic sensor, you have, let's go over them. Ultrasonic, rotary, optical, you have your Hall effect sensors. You could also have metal, you could have metal sensors. That's for a different purpose though. I won't go too detailed into those. But let's go over your ultrasonic. And so what this guy is that this guy emits a wave, right? And this wave, when it hits an object, it'll bounce back into this other eye. So this eye emits, this eye receives, and it'll bounce back. It would use the speed of sound, because it's an ultrasound, which is 343 meters per second. And it'll figure out, because you have time and you have, velocity. Velocity equals distance over time. So that means you could figure out the distance. So velocity times time equals d. Whatever. You don't want to do physics right now. I get it. But with this information, you can figure out where the walls are on your thing, right? And that's pretty cool. It's not as useful as you think it is. I prioritize more into getting a better encoder system, which is your rotary encoders, your optical encoders, stuff like that. Your optical encoders, okay. This is why you don't just buy it all in one piece. Don't try to make your own setup. You'll save yourself a headache. Okay, so optical encoders work like this. You have a disc, and obviously there's a lot more slots than what I'm drawing right now. You have a disc, right? And you attach this disc to your axle. So this is on the axle. So this disc is now rotating, and this is on the same axle that the wheel is on. So when your wheel is turning, the disc is rotating. And what you'd have is you have a sensor that looks like this. And this goes on either side of the wheel, right? And let's draw some wires. And this guy, this sensor thing, would shoot a beam of light across. And so whenever it's open, it'd read a 1, and whenever it's closed, whenever this disc is open, it'd read a 1, and whenever it's closed, it'd read like a 0. So what you could do with that information, you could see how many times it turns off from 1 to 0, and then figure out how many rotations you have. Another thing, don't skimp out on buying quality components. My second robot, V2 over here, I stripped him of most of his parts for V3, but these rotary encoders are originally optical encoders, but I could not use them because after multiple attempts, they were working perfectly fine, and I did have a robot. It was already 12 o'clock before the competition. I had my robot going, and I reload the program, the same program, exact same thing, and they break. And I run through multiple diagnostics, and I just realized that these things are not even getting voltage to them anymore. So these encoders, I got them for like $2, and they worked for like 10 attempts. They just broke on me. So buy quality components, folks. Buy something that'll last you, that won't give you a headache. You want to make this as easy as possible, right? So what did we learn today? I'll make another video explaining some electronics, or you guys could reach out to me. 248-904-0753. Reach out to me on, this is my cell, or here's my Gmail, which is nicoharkin@gmail.com. Cool. Reach out to me on either one of these, and we could talk about electronics. We could talk about robots. I'll help you work on stuff. I'll help you through. But folks, it is a tough event. Make sure you study for your other events, and make sure you study for school too. Spend time designing more than just doing too. You gotta understand that this is your first time, and you can't be too upset if this thing doesn't come out how you want to, because there's some people on here that have been just, planning for this event their entire life. So don't be too discouraged, guys. And with that, I'll see you in the next video if there is one. Peace out, guys. Bye-bye.